That's a football.
Okay, Jack.
Very nice. So nice.
All right, couple things here about your test.
What?
Your exam.
On the phone, you might know.
No.
I'll get your, the ones you took on Thursday, either tomorrow or Wednesday, get them done. I gotta get the seniors done first, and then, they'll have their exams. Cause I got enough seniors in all the different sections that we kinda gotta do things a little bit different. So they'll take theirs Thursday and Friday, and then they're done. What we're gonna do is we're gonna it's easier for me to do an all group review. We're gonna do it Monday, Tuesday, Wednesday. I know about most of you, not most of you, a good bit of you will be out Wednesday, right? Cause we got micro and AP Lang. Okay, so that doesn't, you're not gonna miss anything other than the review. We do a couple things here Thursday, Friday, and Monday. Kind of a little bit of a mini calc preview for next year, and then we'll finish up a couple of things next week in terms of reviewing. But we'll do the main review these first 3 days. You got the review sheet, everybody. I think everybody has it now. And we're gonna kind of do that over the next 3 days. I'm gonna cover a few problems in class that are similar to the ones on the review sheet. Some that I just in the past people have forgotten or just need a little bit of extra help on. Ian, you need it? So we'll do that. So anything that's covered on the review sheet or in class is eligible for the test. I'm not gonna throw any curveballs at you. Where, you get things that we didn't talk about or cover. Everything should be covered. 2 parts, you got no calculator and graphing calculator. You'll take those and once you finish one, you'll do the others. Yours is that Monday, 10:40 to 12:05. And then you can write down the trig identities from the right side of the identity sheet like we have in the past, plus the law of sines and cosines. That's fine. And don't forget, your CCP, or if your CCP at the final exam is 25% of your final grade, which that's kind of a big chunk. So don't start getting in summer mode too early. Okay, so make sure you have that. All right, I want to cover a few things. Like I said, I'll go usually about half the period. I'll cover things today, tomorrow, Wednesday, and half the period I'll give you time to work on it or ask questions. So go ahead and get that down. Like I said, this is separate from the actual review sheet. So you want to find amplitude, period, and phase shift for y equals -7 cosine of 1/6 x minus pi over 12. Amplitude is the absolute value of the constant in front there. So 7, that just tells you how high and how low it goes for that. Period. Avery, you remember how to do the period? No? All right, that's why we review. Connor knows. You don't know? Dominic. Well, let's hope you're fast then. Tomorrow night. Period. Lizzie. Oh wait, that'd be picking up. Sierra.
1/6.
It has something to do with that.
That's
Todd?
all it is.
I know you got it in there.
Distribute 1/6 to pi over 12.
Nope, don't want to do that.
Oh.
Maggie?
It's 2 pi divided by 1/6, so it's gonna be 12.
It is 2 pi divided by b. B is that value there. Good work, Maggie. 2 pi divided by 1/6, 12 pi. All right, that's why we review. Now, period is the length it takes to do one full cycle. So it just stretched out all the way. Usually it's 2 pi for cosine and sine. Remember, tangent's pi. Phase shift. Now this, you usually remember this a little bit better. Alex, you remember phase shift?
Don't you have to set 1/6 times x minus pi over 12 to like 2 pi?
No. All you gotta do is look at that right there. And remember, it moves it left or right. It's kind of opposite. So if it's a minus, it actually moves it to the, remember? If it's minus, it's gonna move it to the
Right.
right. So it's gonna go right pi over 12. Now here's what you might be thinking here. If you have something like this, y equals 3 cosine of 2x minus pi over 4, you got to factor the 2 out first before you can say that. All right. All right, thank you. Elizabeth. We'll be done here soon. Dominic and Tessa. So if you do have that case, you got to factor the 2 out first. You can't say the phase shift's pi over 4. It would be 3 cosine, put the 2 out in front, x minus, and then it would become pi over 8. So that would be the one case you got to watch there. If it's already factored out, you're okay. Ian? For the phase shift? Oh, yeah. Why did I put pi over 6? I'm sorry. Good. Give that man a bonus point.
You're the one who can do that, not us.
That's true. So yeah, pi over 12. I don't know why I put pi over 6.
So are you gonna give up a bonus point now?
Sure, he gets a bonus point.
On the actual exam?
I don't know what on. Just a random bonus point.
You shouldn't do that
It
either.
really doesn't have to go to anything. I'll just say anything. I don't think this one's on the review, but you do need to know.
Nope, don't know it.
So y equals the cosine of the inverse tangent of 5/3. All right, remember inverse tangent, the range, we had to restrict the domain of the original function so that when we take the inverse, we don't get 2 answers. And so that restricts the range of inverse tangent. And remember, it only is defined for quadrants 1 and 4. We can only get answers back from -90 to 90, negative pi over 2 to pi over 2. So since that's a positive, that means it's going to come back in quadrant 1. You're not going to have your calculator for this part. So you got to know how to do. You can't type it in and get an answer. So you need to know that since that's positive, it'll be in quadrant 1. This is the angle. I know the opposite side is 5. I know the adjacent side is 3. Basically, what is the cosine of that angle? Cosine is always adjacent over hypotenuse. Well, I got the opposite, I got the adjacent. Just use the Pythagorean theorem to find the hypotenuse. And so I'll call that R. R squared equals 3 squared plus 5 squared. R squared equals 34. R equals square root of 34. What angle has a tangent of 5/3? Well, this angle in quadrant 1, what's the cosine of that angle? Cosine is going to be adjacent over hypotenuse. So in this case here, y is going to equal adjacent, which is 3, over square root of 34. Now I'm going to rationalize the denominator just in case we have to. 3 square root of 34 over 34. All right, for that one. But
Question, on the no calculator part, do we get the red calculators or is it plain out no calculators?
plain no calculator.
Okay.
Because if you look at the review sheet, like problems like number 2 and 3, you could solve those with the red calculator. So there's no calculator. And it'll be pretty similar to what you see there on 1 through 7.
Cool.
Okay, on that one. All right, so I want to hit one like that. Graphing can be an issue. let's go through the whole thing here with this one. It's similar to the one that's on your reviews, but it's just another example of it. Go ahead and copy that down. Think about the amplitude, period, and phase shift first. You'll get the same thing on the test. You'll just get the x-axis. You'll put in the y-axis wherever it's convenient, which it might be in the middle, it might be to the left, or it might be to the right. All right, amplitude is going to be 3. Period. All right, as we take a look at that one, Mason, how do we get the period?
2 pi divided by 4.
Okay,
Pi over 2.
2 pi divided by 4. Pi over 2 is correct. Phase shift. All right, Dominic, what's going on with my phase shift?
Left pi over 3.
All right, left pi over 3. Now your key points, cosine and sine, all of them can be divided into key points or with the asymptotes, but for cosine and sine, we got 5 key points. For cosine, okay, this is the basic cosine graph. Remember, it starts at 1, goes to 0, goes to -1, back to 0, kind of like a U shape, a well there. Starts at the high point, goes to 0, low, 0, high. Okay, so that's cosine. Do you know how to find the first point from the information given? I want you to think about that. What would be the coordinates of the first point based upon that? Dominic.
Negative pi over 3, 3.
Okay, he is correct. It is negative pi over 3, 3. Because you take a look at what's going on with the phase shift and the amplitude, and the first point usually starts at 0, 1. Well, it's everything shifted left. So instead of starting at 0, it's going to start at negative pi over 3. And instead of having a y value of 1, it's going to have a stretched up to 3 because of the amplitude's 3. So that's your first key point. How do we get those other key points? Okay, that tends to be the harder part. I know that. Esther, you remember how to get those other key points?
You take the period divided by 4.
Yep, you take the period divided by 4, and that is what you add to the x value. So the period divided by 4, which is pi over 2 divided by 4, which is pi over 8. So we're going to add pi over 8. So negative pi over 3 plus pi over 8. All right, take a second, add them together. You don't have any calculator with you for this part, so good little review of your fraction work. Okay, I'm getting a common denominator of 24. That makes negative pi over 3, negative 8 pi over 24, plus 3 pi over 24. And so I get negative 8 plus 3 is negative 5 pi over 24. And the y value, if you take a look at the basic graph up there, is going to be 0 for the second point. Now keep adding pi over 8. Well, that's the same as 3 pi over 24. And I'm just going to keep it like that, just it makes it a little bit easier. And I'm not going to worry about reducing anything right now. So take negative 5 pi over 4 plus 3 pi over 24, which is negative 2 pi over 24. And then that's going to go down to negative 3. Add another 3 pi over 24. and then I get pi over 24, 0. Add 3 pi over 24, 4 pi over 24, positive 3. All right, so get those points down and then think, all right, what's my scale going to be? Because there's more than one correct scale, but there's also incorrect scales. So think about that. Now, I already have mine drawn. I know you don't, but if possible, use the highest denominator, which is 24. Can we go every 24 for what I have shown and fit it on there? Okay, depending on where you put the y-axis. I need to go, that's negative 8 pi over 24. That's 4 pi over 24. If I place it somewhere a little bit to the right, am I going to have 8 marks to the left and 4 to the right? Yeah, I'm going to go every pi over 24. Let's see here. And it's just, I don't have a lot of room, so I'm going to mark it every 2. So that's 2 pi over 24, 4 pi over 24. And I'm not going to mark every one of them. Negative 2 pi over 24, negative 4 pi over 24. As long as it's clear what your scale is, you don't need to mark every single tick mark. All right, go ahead from there, plot your points, draw your graph. And negative 8 pi over 24, which is negative pi over 4, 3. And then I go 1, 2, 3, 4, negative 5 pi over 24, 0. Negative 2 pi over 24, negative 3 pi over 24, 0. 4 pi over 24. Now remember, it's not a V. Don't make it to 2 straight lines. Make sure it's a curve, because at the top there it's going to repeat and keep that same pattern. The other option maybe would be pi over 12. If you want every pi over 12, you could fit it on there and be fine. Right. Equations, directions are important. It says find all solutions. That will determine a little bit of how you go through that problem. And this is one that's similar to one on your review. All right, 2 cosine 4x equals -1. We want to find all solutions. Cosine of 4x is going to equal -1/2. If I got anything other than an x, I'm going to use substitution. I know not everybody does, and that's fine. But I'm going to let theta equal 4x. And so this becomes cosine of theta equals -1/2. And I wanted you to think, what 2 angles between 0 and 2 pi is that true for? So take a second and think about that. Where's cosine of theta equal -1/2? And that's similar to like the first ones that are on the bottom of your review sheet. Jackson, you remember what those angles are?
120 degrees and 240.
All right, good. 120 and 240. We're going to convert those to radians here in a second. But remember, cosine's 1/2, -1/2. It's going to be in quadrant 2, in quadrant 4. That means my reference angle is 60 degrees. That means that's going to be opposite. It's going to be radical 3/2. And that means I get 120 and I get 240. 120, 2 pi over 3, right? And then 240 is 4 pi over 3. And this is what we do here. So theta equals 2 pi over 3 plus 2 pi n. Remember, it says all solutions, and theoretically there's an infinite number of solutions. It just keeps repeating. And so theta also equals 4 pi over 3 plus 2 pi n. Now I'm going to take out the theta and put in 4x. And I'm going to take 4x equals 4 pi over 3 plus 2 pi n. All right, on the left, we're going to get x by itself. Divide everything by 4. So I divide by 4, divide by 4, divide by 4, and I get x equals, all right, 2 pi over 3 divided by 4 is the same thing as 2 pi over 3 times 1/4, 2 pi over 12, pi over 6, plus pi over 2n. Divide everything over here by 4, and I get x equals 4 pi over 3 divided by 4 is 4 pi over 12. If you just take a second and look at it, it'll reduce to pi over 3 plus pi over 2n. I'm going to get rid of that there. All right, I'm just going to write a little bit neater for my final answer. Typically what we did was we would say x equals the two sets here, pi over 6 plus pi over 2n, and then pi over 3 plus pi over 2n for any integer n. Okay. Okay. All right, we're just going to do one more here together.
No.
And don't forget that you do need to put the for any integer in. All right, let's take a look at identity. The goal is we get nobody missed the identity on the exam. All right, write that down. Just kind of think through maybe what you do. I'd wait, hold off unless you were absolutely confident you know what the right step is. But just kind of think, what could we do? What do we need to do? And then we'll kind of go through there together. All right, cosecant. One of our rules is convert everything to sines and cosines before you quit. Like, that doesn't necessarily mean it's always going to be the step, but majority of the time it's one step. So cosecant, don't forget that is 1 over sine of x. And so that becomes 2 over sine of x. All right, nothing we can really do from there. Leave that. All right, left-hand side. Sine of x over 1 plus cosine of x plus sine of x over 1 minus cosine of x. All right, ideas. Going through them. Dominic.
Square sine, then make it 1 minus cosine squared.
All right, give me a little more details. For both of them?
Just for one, right? For, you have to do both.
Okay, I see what you're getting to. I don't know if what you're saying is going to be.
Please re-explain that.
What's that?
Please re-explain.
Yeah, say that again.
Well, 1 is equal to cosine squared plus sine squared, so sine squared is equal to 1 minus cosine.
Okay, so you're saying that's cosine squared plus sine squared, right?
Yeah.
All right, you can do that, but then you got that problem with that cosine of x, because you can't square that without squaring that. You're going to get into a mess there. And I know what he's saying. Don't write this down. He's saying cosine squared x plus sine squared of x can replace that. But we're going to run into issues with that right there. You got the right idea. You got the right idea. but we're gonna have to get to it a different way. What'd you say?
Common denominator?
Common denominator is one thing we can do. So we're gonna add those together because that's gonna help us with that. So it says to add them together. In order to add them together, we've got to get a common denominator. So I'm gonna take your first term, which is sine of x over 1 plus cosine of x. And I'm gonna multiply both of those by 1 minus cosine of x. Plus sine of x. And then you got 1 minus cosine of x is your original. Multiply that one by 1 plus cosine of x. Okay, they both have 1 plus cosine of x times 1 minus cosine of x. Distribute your sine of x. So I get sine of x minus sine of x cosine of x plus sine of x times 1 is sine of x plus sine of x cosine of x. So in the numerator, we do get minus sine cosine of x and plus sine of x cosine of x add up to 0. You're going to be left with 2 sine of x. Take a look over there on the other side. You got a 2, so that's helpful, but it's 2 over sine of x. Can't leave this 1 plus. You don't see any cosines over there. First thing you should do is multiply those together. If I FOIL those two together, I'm going to get 1 minus cosine squared of x. What does 1 minus cosine squared of x equal? Sine squared. Okay, so now you get 2 sine of x. 2 sine of x over sine squared. And then I'm just going to put over here, this is just for me, that 1 minus cosine squared of x equals sine squared of x. They cancel, and you're left with 2 over sine of x, which matches up on the other side. Okay. So just kind of remember your identity rules. You're allowed to write the right-hand side down on the sheet of paper to use. That'll help you. But just kind of understanding a little bit of your identity properties. All right, Ash, try and get through. I'm not collecting the review. You're not gonna have to turn this in. But do 1 through 7 if you can tonight. That way you can come ask questions tomorrow. So A, we'll go over questions, and then we'll kind of review a little bit of the calculator part. We're gonna try to break this up into 3 days. For that.
One of the languages.
I know. That's a lot.
Cause look, we got 6 questions.
I think it's perfect.
You already got it done.
I got the first page.
That's pretty good.
1 through 3.
Yes, you guys can go, Elizabeth, you can go.
Okay, yeah.
I'm like, you got nothing.
Nothing.
That's stop. Stop, Lizzie.
We calculate back to
Comments here and there.
Okay, so you
No.
go fine.
Come on.
So I'm in Greenville. I have.
May use the restroom.
You, man.
No comments here at all?